Okay, in this video, guys, we're going to go ahead and cover the next topic for this class, hb5, and that's number properties. The first page is a lot of just copying. So you have this definition, the additive inverse. I would pause the video here, copy it, and then listen. The additive inverse is just going to be the opposite of each other. So in other words, if you had, for example, -3, the additive inverse is just 3. That's why it says if you add them together, they make a 0. So again, you kind of have the formal definition here, a plus -a equals to 0, where a is any real number. This right here just means a belongs to the real numbers, and a is not equal to 0. Because if this was 0, well then this would be -0, and that's not a thing. So anything except for 0. So again, you can make a equal to anything you want besides 0. So you could even do like 1.4, and this would be -1.4. So if I'm asking you for the additive inverse, it just means take the opposite sign. So if this is positive, make it negative, and vice versa. Second definition you're going to want to copy here is reciprocal, and we kind of talked about this in class yesterday. A reciprocal is the flip version, right? So it's a number that if you multiply, it's going to give you 1. What does that mean? I'll show you in just a bit. It's also called the multiplicative inverse because, again, if we multiply it, it gives you the 1. Here's what we saw yesterday, the reciprocal of some number, so 3 over 5. It's just 5 over 3. So you just flip the numbers. What goes on the top goes on the bottom. What goes on the bottom goes on the top. And if you multiply these two together, and I'll do it here on the side if you want. We had 3 over 5 times 5 over 3, for instance. That's what we have here. Well, we learned yesterday, you just multiply across, right? So 3 times 5 is 15. 5 times 3 is 15, and 15 divided by 5 is just 1. Yay. So this will always happen. So when you do reciprocals or multiplicative inverses, you multiply by the same thing but flip to get that 1. And here's the formal definition. A over b times b over a. These two things, if you put them together and this together, you have the same thing. So it just gives us the 1, where a and b are just, this is the symbol for integers. So in other words, these are whole numbers, okay? An integer, in case you've never heard that word, is any whole number, whether it's negative or positive. And we do have the condition that it cannot equal to 0, because again, if you have a 0, you would have division by 0 on one of these, and that's not allowed either. Okay, so far just definitions. Then we have some properties here. We have the commutative property and the associative property. The commutative property, there's two of them. There's the addition one and the multiplication. And this one just says that if we add something, it's the same thing on both sides. So a plus b is the same as b plus a. So if you kind of wanted to think of an example, you could say like 1 plus 2 is the same as 2 plus 1. Simple as that. Oh, and actually I did give an example. We have this one. 2 plus 3 is the same as 3 plus 2. So you just swap the numbers, okay? Multiplication is another one that has a commutative property. So, but for multiplication, we're multiplying. So we have a times b is equal to b times a. So again, two numbers, we swap them. It's the same thing. The order doesn't matter because we're still going to get the same answer. And that is the commutative property. The last property you have to copy is associative properties. And this one has to do with parentheses. So you'll notice that we have a plus b in the parentheses and then plus c. Since we're going to just be adding here, what happens is it doesn't matter where you put the parentheses. So this is the same as putting the b and the c in the parentheses. You're still going to add the numbers across regardless. So here's an example. 2 plus 3 plus 8. Let's see, 2 plus 3 is 5, plus 8 is 13. So we have 13 on this side. And over here we have 2 plus 3 plus 8. So 3 plus 8 is going to be 11, plus 2 is also 13. So, it does check out. Last one for associative property is multiplication. So we're multiplying here a times b in the parentheses times c. And we can just move the parentheses around and we'll still have the same thing. You have an example kind of squished here in the corner. 5 times 4, that's going to be 20, times 2 is 40. And if we swap it and we do the 4 and the 2 first, 4 times 2 is 8. 8 times 5 is still 40. So it does not matter where we put those parentheses because we're just multiplying and it gives us the same answer regardless. Okay, so make sure you have all these in your notes. I'm going to do some examples now that go with these definitions. And this part's going to be kind of quick. So remember, you can always Pause as needed, okay? Find the additive inverse of each. So additive inverse, again, is just changing the sign. So for this one, the additive inverse, if I want to make this equal to 0, would be positive 8 over 9. So 8 over 9. Done. Because if you add negative 8 plus 8, that gives you the 0, right? For this one, we have the additive inverse of 3. So how would I make this equal to 0? Well, I could subtract 3. So my additive inverse is just negative 3. Just change the sign. Next one, additive inverse of negative 5. Well, the opposite of negative 5 is positive 5. So not too difficult. You just have to remember what it means. Additive inverse. This is when you do the opposite sign. Okay. Negative 3.7. Well, the opposite of negative 3.7 is positive 3.7. Again, piece of cake. This one is to find the reciprocal, and you have this expression. So what you're going to do here first is you're going to simplify this, because this is just an expression, right? So we're going to use PEMDAS, and we're going to figure out what this equals, and then we'll find the reciprocal. So we have parentheses first, right? So the parentheses I see here on the inside do have more than one number. So let's deal with that first. We have negative 4 minus 7, that's negative 11. I'm just going to copy everything after that. I left it in parentheses just to kind of, distinguish it. So we have all this, okay? And then we still have a parentheses here, but there's nothing else going on in there, so I'm going to just kind of leave it. I'm going to move on to the square. 3 squared is like saying 3 to the power of 2, which is 3 times 3. So this right here, this is 3 times 3, which is, 9. So that's going to be 9. So now I can bring everything down. Negative 11 minus 9. This is in the brackets. Okay, and now I did take away the parentheses because, well, we already simplified this part. So now I just, I can kind of write it out a little bit nicer. And then negative 11 plus that. Brackets can be treated like parentheses. So it's like another set of parentheses. So that's all I'm really thinking. I'm saying negative 11 plus, since it's a parentheses, I can take it away. Negative 11 minus 9. And here, we just have, a bunch of negatives. So negative 11 and negative 11. If I add them, it's negative 22 minus 9 from here. So again, we have same signs. So we add them and keep the sign. 22 plus 9 is going to be 31. And since they're both negative, this is going to be negative 31. And so we want the reciprocal of this. So the reciprocal of negative 31, we have to have kind of a fraction for that. So what I'm going to do now is I'm going to rewrite this as negative 31 over 1, because that's how I'm going to flip it. I have to flip, two numbers. So if this is my answer, the reciprocal would be to flip it. So my reciprocal is going to be this number flipped. So 1 over 31, and I put the negative on the top like that. And that is my reciprocal for this problem. Okay, moving on. These are pretty quick. We have use a commutative property to complete the statement. So all you need to do is apply the properties that we saw before. Remember that commutative just means that we're just kind of switching the position. So 2 plus 1 equals 1 plus 2. So in this case, if I want